Hi, everyone. Thank you all for tuning into our panel discussion on the science behind Alexa AI. My name is Yang Liu. I'm a principal applied scientist working at Alexa AI. This video is pre-recorded, so we cannot take your questions live, but there are many opportunities for you to connect with our scientists during and after the Interspeech conference. So we highly encourage you to visit our virtual booth to meet with us and learn more about Alexa AI. We're very excited to connect with you throughout this week. I'm very pleased to welcome my colleagues, scientists Karthik Gopalakrishnan, Will Hamza, and Fabian Treffenbach. They are scientists working primarily on Alexa AI, but along with other scientists at Alexa AI, they are driving the customer of science, the science. So first, let's take a few minutes to introduce ourselves. As I just mentioned, my name is Yang. I'm a principal applied scientist at Alexa AI. I'm working on both open domain as well as task-oriented dialogue. So this involves language understanding, response generation, and then some other aspects of dialogue. Some of you may have heard Alexa Prize Social Bot Grand Challenge. This is a challenge organized by Alexa AI. It's a university competition that encourages university student teams in developing social bots so we can push the boundaries of conversational AI. For this new year, the 4th annual challenge had just kicked off with a call for application proposals. We are very looking forward to seeing the new results coming out from this new round. And by the way, I'm also on the organizing committee for this year's Interspeech conference. So Karthik?
Sure. Hi, everyone. My name is Karthik. I'm an applied scientist at Alexa AI. I work on generative and retrieval-based models for knowledge-grounded dialogue, and I focus primarily on open domain dialogue. And I work on this along with Yang and a few others on our team. I joined Amazon after school because I wanted to apply the foundations that I built in school in machine learning towards like problems that directly impact customers.
Thanks, Karthik. Will?
Thanks, Yang. Yeah, my name is Wael. I am a principal applied scientist in the Alexa AI organization. I lead a team of scientists. We work on deep learning algorithms and methods for natural understanding. My team focuses on problems like understanding the input of the customers to Alexa. That includes the domain classification, intent classification, slot filling, semantic parsing, and various other natural understanding methods. I'm really excited to be part of Alexa, particularly Alexa, because it's actually an opportunity for me and scientists like me to apply all the machine learning, knowledge and ideas to something that goes directly to serving customers. The values that Amazon holds dear, such as customer obsession, bias for action, think big, and other principles, make our life as a scientist more exciting than just coming up with an idea, but just taking those ideas and putting them in front of customers to have an impact using machine learning. So that's a bit of excitement about my life at Amazon and particularly Alexa. I can pass it to Fabian.
Hi, my name is Fabian. I'm Applied Science Manager located in Aachen, Germany. And in Aachen, we actually have multiple teams working on Alexa's speech recognition and natural language understanding components. And my team specifically, actually, we try to streamline feature and language expansion for Alexa NLU. So we want to teach Alexa new languages, new capabilities, and we want to make that process as easy and as painless as possible for our scientists and developers. And to do so, we focus on areas like deep learning, data augmentation, cross-lingual learning, and all the aspects that help us to reduce human effort and data needs to expand Alexa to new marketplaces and to delight more customers with these experiences. And what brought me to Amazon is actually that I joined like more than 6 years ago in the very early days of Alexa development when we just started to build the product. And before I did a PhD on speech recognition using neural networks, and my motivation was mostly to apply this research to actual problems, to actual products, and to develop the large-scale solutions which we were thinking of such solutions could help with, and to bring them to production and to really delight customers by building products that are really used by millions of people these days.
Thank you all for the introduction. So you see whether we are located in different places, California, New York, and Aachen, Germany. And I know all of us here have written or authored some of the publications that have been accepted or will be presented at the conference soon. I want to touch on some of the papers or the research coming out of these papers. Will, maybe you can start by giving us some summary of the research that your team is going to present at Interspeech.
Sure, Yang, thanks. Yeah, so one of the papers I would recommend that people who are attending Interspeech to look at is our paper regarding the style. It's actually entitled Style-Attuned Pre-Training and Parameter-Efficient Fine-Tuning for Spoken Language Understanding. And as you know, and as I said in the introduction, that we develop machine learning algorithms and methods to handle customer input, to understand customer input, and our customers talk to Alexa regarding many subjects, music, weather, shopping, home automation, so many of these applications. We also allow third-party developers to develop their own domains, which we call in Alexa skills. And as known to the community, deep learning models to understand all these domains are going to be heavy models, and to have deep learning models for all these domains may be difficult to train and difficult to serve in production. So the paper shows a very interesting way of pre-training those models or big portions of these models, and then use these pre-trained models into domain-specific or task-specific model. The problem is if we use a deep model, a full deep learning model for task-specific models, we will have a huge, humongous size of model, and it may be difficult to train and difficult to serve. So the paper shows that we can actually pre-train a big portion of the model and share it between all the domains and all the tasks, and only add a little bit of task-specific or domain-specific set of parameters to actually serve all these domains and all these skills. The paper shows that by adding 4% of the parameters, we can add a new domain or a new task or a new skill without affecting the performance. We also have shown in the paper a few techniques of how we do that and how we train, task-specific models without losing performance from the final model. So we're excited to present this effort, and we're happy that it is coming to Interspeech.
Thanks, Will. Well, this is a good example of customer-obsessed research. Paper is trying to address a real-world problem. Karthik, I know you are the primary author for a paper that looked at whether the neural network-based models for open domain dialogue systems and whether this kind of approach is robust to speech recognition output. Can you tell us more about it?
Yeah, sure. Thanks, Yang. So basically, very large pre-trained transformer-based language models have become ubiquitous in NLP, and this has led to like a renewed focus and interest in the community on end-to-end neural open domain chatbots. That is like bots that can directly generate or retrieve responses given a dialogue history. And like state-of-the-art open domain chatbots have been built using such large language models, but the underlying assumption with these models is that the user input is like in the form of written text. But as in Alexa, speech is like a popular modality due to the ubiquity of assistants like Alexa. So we asked ourselves the question, can like large text-based end-to-end open domain chatbots like seamlessly integrate with ASR models to support this modality? And ASR models are essentially imperfect allies in contrast to like perfect adversaries. And there's been a lot of work on adversarial attacks and perturbations on language models. So what we did was we adopted like an empirical first principles approach, and we performed allied attacks to a state-of-the-art GPT-based open domain dialogue system in the form of synthetic and actual ASR errors. And we demonstrated that such errors can hurt the performance of these systems significantly. And we also demonstrated like marginal gains from like a simple mitigation strategy of introducing such errors during training. And there's like a considerable room for improvement. Like the goal of the paper was to primarily promote speech robustness as an evaluation criterion in open domain dialogue and foster research towards making end-to-end neural open domain dialogue models more speech robust. And in this spirit, what we also did was we also open sourced the dataset that we used for our study, which we call topical chat ASR, which is just an ASR augmentation of the largest open domain text-based dialogue dataset, topical chat, which was also released at Interspeech last year, actually.
Thanks, Karthik. I'm very glad I'm also a co-author on that publication. We all know in goal-oriented dialogue systems, there's a lot of research looking at how speech affects the spoken language understanding performance. And we hope our publication will let the community pay more attention to open domain dialogue systems. And I also want to briefly mention 2 other interspeech papers I have co-authored. Both of those are related to entity recognition and entity linking. One paper is about entity linking, also called entity resolution. When a user mentions an entity, for example, San Francisco, it may mean multiple things. It can be the city of San Francisco, it can be the airport, and maybe a sport team. So we need to resolve that entity to a real world object. And in this paper, we use rich information to decide what the entity refers to. And the information includes the context of where the entity has appeared, the description of the entity itself, and the relationship of entity with others in a knowledge graph. And we showed good results. Another paper is about the correcting ASR errors for entity recognition and entity retrieval. For speech recognition system, some of the entities are out of vocabulary words, and they often cause recognition errors. In this paper, we use a transformer-based model that incorporates phoneme information, trying to correct ASR errors for entities. And we show the improvement for both recognition performance for entity words, as well as downstream entity retrieval tasks. And okay, I'm going to pass to whether Fabian, you team has a paper on spoken language understanding, looking at the low frequency classes. Can you tell us more about that research?
Yeah, sure. So the problem we tackle here is actually a real world product use case. So the situation is that the usage patterns of voice assistants like Alexa, they're very imbalanced. So it is very often that the distribution of intents and slots is very skewed. And in practice, that means that we observe many high frequency used command and control requests, like, I don't know, music requests or turning on and off devices via home automation. But other features are less frequently used. For example, starting this smart home discovery mode on the device, which is rarely used, but still very important. So these features with little usage, they're not always less relevant, but just less frequently used. So let's take a very practical example. So if you lost your phone at home, you might, for example, call it via Alexa just to try to find it back in your apartment. And while this is a very rare use case that you don't ask this very often for your own phone, if you do, it should always work, right? Because you want to ensure the greatest customer experience. So there are many more of these examples, and they're also even inside specific features. There are very different ways how people request functionality, and given the large diversity of our customer base, there's a lot of way how this is done and a lot of flexibility in the user requests. So this kind of imbalancing of the data has not been really studied at scale for natural language understanding in literature, and this made us actually curious to solve the problem and to tackle it from a more research angle. And in the paper we brought to Interspeech, we actually address it by trying to get the tail of the less frequent utterances improved in quality, but without impacting the quality of the head of the intents and slots. So we try to really move up the tail by not impacting the great customer experience on the things that are frequently used and always work in a high quality. So in the publication, we propose to use different data balancing solutions, which are sometimes very classical approaches, but we also leverage an auxiliary task training, which makes use of a new class balanced batch generator. And this incorporates additional synthetic training data into the workflow. So by teaching the system to actually focus on the less frequent examples, we demonstrate that there are great potential for improvements on the tail, but without any degradation on the head intents, so the frequently used functionality. And in addition, we also demonstrate and studied a little bit how synthetic data in the life cycle of feature development can be used, and what is the best way to bootstrap new features, while later balancing more realistic data with synthetically bootstrapped data, and when is the time to actually fade out old data, when to use new data, and when this auxiliary task training can help us to focus on the right data at the right time in model building. So this is what we address in this publication, and it's, as I said in the intro, a very customer-facing solution we drive here, because it helps our customers to just get a better experience, and by not having any degradation on known experiences and known features they're used to.
Thanks, Fabian. That's another good example of research trying to help with real user experience. Thank you all for the summary of what the publications you have co-authored. And you may have noticed that this panel of scientists that is primarily focused on areas of natural language understanding, NLP, or dialogue. We all know Alexa Science also has many scientists working on speech processing related fields. And actually in this conference, there are many other papers by Alexa scientists about the speech recognition, ASR, TTS, wake word detection, speaker diarization, rich transcription, SOU, etc. Will, maybe you can share with us your thoughts on how NOU in Alexa AI works in concert with other areas in speech, such as acoustic models or ASR.
Yeah, thanks, Yang. Someone like me who worked with ASR before, spent almost half of my research life doing TTS, and now to natural language. I tend to believe that I know more of these things, but as you said, the areas of research and science progress across all these disciplines and areas of research is becoming a lot, and you can tell from the Interspeech publications how much effort is done in this area, particularly also from Alexa scientists. And I invite all of you to attend some of the panels also that are going to be attended by our science colleagues from the ASR and the WakeWord and the TTS team, to get an idea also of what is happening on these fronts. And this session and the other session will also be available on Amazon Science website. I would like to bring the attention to something that that is becoming popular also in the research community, which is demolishing the boundaries between those areas of research. And now we are beginning, the community is beginning to look into solutions that are end-to-end solutions. So one of the areas that are becoming popular is the area of doing NLU on the speech signal directly. So you take the speech as input, you don't do ASR followed by NLU, you just do NLU right away from speech. And we regret to miss Interspeech for one of the papers we have been working on, but we promise to publish soon. But you can find maybe several of these papers in Interspeech and in other conferences. It's an area of attention nowadays. Another area of attention is to, instead of acting on what the ASR produces, the NLU systems, for example, would act on the word lattices or N-best output of the ASR systems, which gives more robustness to ASR errors, and it helps make the NLU and subsequent components much better. A lot of exciting areas on these combined and end-to-end systems that I invite all of you to look into and do research on.
Thanks, Will. And indeed, there's a lot of work on end-to-end SOU, starting from the speech signal all the way to the final understanding results. And even just in terms of the approaches used for ASR, TTS, and NOU, SOU, there's a lot of similarity. Pre-trained language models, transformers, sequence approaches are used in all of these problems. So yeah, the boundary is getting rather blurry. So thank you to all of you for sharing these insights and then giving us some summary about the research you have been involved. To close out, I would like to hear from each of you on where you see the future headed. And for myself, I have been in this field for more than 2 decades, and I've seen a lot of progress, especially in the past few years in speech and NLP, mostly because of deep learning approaches and more computing resources and large amount of data available. So what are you most excited about? Where do you think whether there will be challenges or what's next for conversational AI? Karthik, maybe you can start.
Sure. Yeah, so I think I'm really excited about scalable training of larger language models for desirable downstream attributes. So, like I had mentioned earlier, language modeling as a field, and more specifically, open domain dialogue as a subfield, has seen a spurt of larger language models trained on very large amounts of data. And some generally desirable attributes from such language models include, like, factually accurate and bias-free sequence generation. More specifically, downstream in open domain dialogue, like, some other desirable attributes would be like accurate grounding of knowledge, empathy, common sense, system persona, user personalization, etc. And these are all very hard challenges, and the open domain dialogue community as a whole is doing quite interesting work along these lines. One challenge I think I'm especially looking forward to is like effectively incorporating the notion of temporality in large language models via continual learning mechanisms, given that world knowledge constantly evolves. Like an example of this would be the pandemic that we are living in right now, the coronavirus, which isn't something that dialogue models that were trained prior to 2020 would have been capable of talking about. We've seen and learned quite a bit about how these models perform in production through the Alexa Prize. So I'm also quite excited to see work on just closing the training loop with production and enabling, like, parameter efficient adaptation.
Thanks, Karthik. Will?
Yes, lots of excitement about many areas. One of the areas that the community is, excited about and working on is the area of understanding more compositional input from the user. Currently, the majority of AI agents just try to detect the intent and fill some slots from the user input, but creating a full semantic parse from the input of the user is one of the areas that are becoming very interesting and very challenging at the same time. Another area that is becoming also very popular and I'm excited about is the area of using the contextual information beyond the user input. What is happening in the news, what is on the screen while the speaker is talking, the previous interaction with the agent. So this is an area of also interest and research. For an area that my team is also very excited about and interested in is people are building those huge models, BERT and BERT large and XX large and now GPT-3 and bigger models. So there emerged an area for distilling and compressing and pouring these models into much smaller sizes, order of magnitude smaller sizes that can be practically served. We see a lot of publications in this area and a lot of interest in this area. Very exciting area and very interesting as well. One of the challenges that people also face, and it's very popular in research, is to be able to learn from very, very little amount of data, similar to what Fabian described in his paper. Very challenging because, annotating data and getting, supervised signal to training is not an inexpensive process and sometimes very expensive process. So building models that can learn from unlabeled data, that can learn across tasks, transfer between tasks is a very popular area of research. Few shot learning, zero shot learning. This is a very interesting area of research. Finally, we have been after accuracy for a long period of time. So the community now is looking into aspects other than accuracy. So there is a very, very important interest, especially for conversational AI agents, to keep the customer privacy in mind, building models that are protective of the user privacy and as well as provide the bias-free experience to our customers. The agent should, interact with the customer in a bias-free fashion, and at the same time, these models that are built and these, systems that are built are very protective of the customer privacy. So these are a few headlines of what our teams are interested in and the community is interested in.
Thanks, Will. whether those are exciting, and I think whether those are important for both Alexa or Amazon, as well as the entire speech and NLP community. Fabian, can you share your thoughts?
Yeah, I'm also very excited to actually see how much the field is evolving over the past years. So seeing that NLU is really breaking out of these classical boundaries of dialogue systems, classical command and control use cases. So showing much more naturalness, more interactions, more self-learning and other cases, that is really great to see. And especially as mentioned by Wayland and Karthik, all the deep learning and large-scale language modeling applied to NLU. They're, from a product angle, really enabling us to build many new experiences, for customer experiences. So we will have more natural, more appealing, and much more interactive devices on the market in the future. And this is really great to see how this field is evolving. And especially looking at this related to our publication, like pre-training and distilling such general purpose models or general language models into very specific problem domains or spaces is super great, because it helps us to reduce reliance on data, and we can really port the world knowledge into our problem space and benefit from large scale backend models. And from the aspect of multilingual modeling, it's super interesting for me personally to see that one actually can combine multiple languages in these models, and there's the possibility to leverage cross-lingual synergies, cross-lingual learning, and this will help us a lot to build our systems in a more global, more language agnostic way, without thinking about, I build a model now for this language. We really will be able to serve customers in multiple languages with a joint effort, because we can really learn across these languages, because we will map like different languages into the same space. We will learn relations among them in this shared space, and it's very elegant and efficient to do. So I'm personally very excited and looking forward to see many more of these publications around multilingual and large-scale modeling that helps to build real business applications out of that.
Thanks, Fabian. I believe with advancement from all of these areas, what our panelists has mentioned, Alexa is going to continue to give user better and better experience. Well, with that, we are coming to the end of this virtual discussion. And I want to thank my panelists for sharing their insights and their research. And I want to thank everyone for tuning into this virtual event. I encourage all of our viewers to access the publications during Interspeech, so you can know more details about the research from these panelists and also other Alexa scientists. These publications are also available on our website, amazon.science, where you can find these publications as well as other content about our approach to customer-obsessed science. We would love to connect with you during the conference or after the conference, so please feel free to drop by our virtual booth, and you can schedule a meeting with any of the Alexa scientists. We'll be happy to talk more about Alexa AI or Amazon. With that, enjoy the rest of Interspeech conference.